Hey everybody, your Friendly Math Tutor here with our AP Calc BC practice test. So in this series of videos, I'm going to solve every problem from a practice test. Here in video 1, we're going to start with section 1, part A, where we have 28 questions and no calculator is allowed. So let us begin with number 1. So we have a set of parametric equations and we want to know the acceleration vector. So we could look at it like this. So the position vector, I'll call S of t, would be sine 2t cosine t. So that's just what's given. And the derivative of position is velocity. So the velocity vector will be just the derivative of this. So the derivative of sine is cosine. So we get 2 cosine 2t. Use the chain rule. Derivative of cosine is negative sine t. And then the acceleration, I don't know why I wrote v prime. That's just v, my bad. That is s prime. And then a of t would be the derivative of v of t, which is negative 4 sine 2t. And then negative cosine t. And then they want so a of pi over 6. All right? So that is, when I do pi over 6, 2 times pi over 6 is pi over 3, and the sine of pi over 3 is root 3 over 2. So I get negative 4 root 3 over 2. We'll simplify that in a second. And then the cosine of pi over 6 is also root 3 over 2. So we get negative root 3 over 2. So this becomes negative 2 root 3. So we are left with C, which is negative 2 root 3 and negative root 3 over 2. All right, now let's move on to number 2. I think in this one I like using U substitution. So I am going to make u sine x, which means du is cosine x dx. Well, this works out perfectly because now I have the integral. This cosine x dx, usually I solve for dx and substitute, but this cosine x dx is just right there, so that's du. And then I have du over u squared, which is really the integral of u to the negative 2 du. And now I reverse power rule this, and I got negative, well, I get u to, I'll do it the long way, u to the negative 1 over negative 1 plus c, which is really negative 1 over u, but u is sine. And I think I can stop there. Again, this is like any multiple choice test. You stop as early as you can when you know the answer. So you might have been able to know the answer back here, but negative 1 over sine is certainly negative cosecant, so we get that answer. There is a way to simplify first using trig identities, but I thought it was easier just to start off with U substitution. All right, the function given by this has a local minimum. All right, so I am going to do the first derivative test. So I'm going to find f prime. Let's remember we're doing the product rule, so the derivative of this is 2x, and then keep the second function the same. Then keep the first function the same and multiply by the derivative, but the derivative of e to the x is e to the x. And then I want to set this equal to 0. I'm also going to factor out the e to the x. And then I'm going to write this in order. This is really, I have a 2x here, and then I have an x squared minus 3, but I'm going to put it in order, x squared plus 2x minus 3. And then I have e to the x, and this should factor nicely to x plus 3, x minus 1. Let's realize that something like this, just ignore in the first derivative test, because e to the x, not only does it never equal 0, it's always positive, so it won't affect the signs. So I have negative 3 and positive 1. If I choose a number over here like -4, I'm going to get two negatives, so that's a positive. If I choose a number between here, like 0, I get a positive and a negative. That makes a negative. And a number bigger than 1 makes them both positive. And a local minimum, let's remember, a local minimum is decreasing to increasing. So that's going to occur when x is equal to 1. You could do second derivative test there, but why take the second derivative of this? I feel like first derivative test is a little bit easier. All right, moving along to number 4. We are looking for a limit. The first thing we should always do when we're taking a limit as x goes to that numerical value is just substitute it in and see what happens. Well, the sine of pi over 2 is 1, so I get 0 on top, and the cosine of pi over 2 is 0. 0 over 0 should just be a cue to your brain. It should just be L'Hopital's rule. So it's the limit as x goes to pi over 2. I'm going to do the derivative of the numerator, which is negative cosine, and the derivative of the denominator is negative sine. And now I'm going to substitute again. Well, this just gives me 0 on top. Well, let's see what we get on the bottom. Now I get -1 on the bottom, and 0 divided by anything other than 0 is 0. So our answer is B. All right, let's keep it moving. So number 5, we have a sequence problem. Now, these are not series, all right? So whether sequences converge are simply just the limit as n goes to infinity, all right? Rather than write that out, I'm just going to do a little bit of a shorthand, well, at least for the first one, because if I take the limit of this is a rational function, the degrees are the same, so I am just going to get 2/3. These are like those pre-calc rules you would have learned about horizontal asymptotes. So that definitely converges because it goes to a numerical value. All right, let's not get confused with the divergence test or the nth term test, which those have to do with series. This is just the sequence. So now we look at number 2. Well, number 2, this is infinity over infinity, so I can do L'Hopital's rule. So this one I'm actually going to write out the notation. The derivative of the numerator is 1 over n, and the derivative of the denominator is 1. So it's just 1 over n, and 1 over infinity we should know goes to 0. So this one converged to 2/3. This one is converging to 0. And then number 3, again, when I think about like evaluate, not really even evaluating, when I just think about when n goes to infinity, these both go to infinity, so I am going to use L'Hopital. Derivative of e to the n is e to the n. Derivative of n squared is 2n. Well, then that's going to be L'Hopital again. Because they're both infinity. Now I get e to the n over 2, and that's infinity over 2, which is infinity. So this one diverges because the limit of the sequence goes to infinity. So that means the answer is 1 and 2 only. All right, the tricky part of that problem is we're so conditioned now on how to use series and nth term tests and p-series and such, and geometric. This is none of those. This is simply actually just limits, more so than anything to do with your typical like unit 10 infinite series stuff. All right, let's keep going. We got number 6 here. Which of the following is the length of the path parametric equations? We need to know this formula. Arc length is the integral between our two values, which is, I'm going to right now just write t sub 1 and t sub 2 because I'm just writing out the formula. And then it's the square root of x prime of t squared plus y prime of t squared. We got a little bit of Pythagorean theorem going on here. This is just the arc length formula. So this is just a simple kind of just like plug and chug, at least to start. We're evaluating from 0 to infinity. I'm taking the square root. I want to find the derivatives of these. So x prime is 2 cosine 2t. Y prime is negative 2 sine 2t. Then I'm going to square those. So I get 4 cosine squared 2t, and then a plus 4 sine squared 2t dt. So here's kind of just like a little tip. A lot of these types of problems, arc length problems, are given on the calculator section because the integrals are usually way too difficult with this square root here. Except in these cases, because I can factor out a 4. So what I really end up with is the L equals from 0 to pi. If I factor the 4 out, I get cosine squared plus sine squared. Well, we should know that that's 1. So I only have a 4, and the square root of 4 is 2. All right, so now I have an integral. So this is typically what's going to happen on a non-calculator arc length problem. I realize that's pretty specific, but if you're studying for this test, these are the types of things you need to know. So integral is 2t, evaluate it from 0 to pi. I think we can stop there because when I plug in pi, I'm going to get 2 pi. When I plug in 0, I'm going to get 0. So the answer is 2 pi. All right, so no way around that one. You got to know the arc length formula. All right. All right, number 7. So we need this function to be differentiable, which means we also need it to be continuous. I am going to show the work, but this kind of stuff, again, on a multiple choice test, you want to, you don't have to write out all the limit stuff. I mean, sometimes it should be important, but what we're doing here is we're doing the limit as x approaches 2 from the left of x squared minus 2, and then the limit as x approaches 2 from the right of ax plus b. We should also be finding f of 2, but we know that that is going to be the same as this, so I'm not going to find that because I'm just going to get 2. Right? When I plug in 2, 2 squared is 4, 4 minus 2. Then when I plug in 2 here, I'm going to get 2a plus b. So my equation now is, I'm going to write it up here, 2a plus b has to equal 2. All right. Well, now I need the derivative. I'm going to do that over here. So the derivative of this, of a piecewise, is just another piecewise. So the derivative of x squared minus 2 is 2x. Derivative of ax plus b is a. So if I then do the limit as x approaches 2 from the left of 2x, and the limit as x approaches 2 from the right of a, that is what's going to make it differentiable. It's basically differentiable. It's kind of like the derivative has to be continuous. So here I get 4, and here I get a. Right? I'm not plugging in 2 for a, I'm plugging in for x, so it's just a constant. So this means a is equal to 4. All right? So that gets rid of this one and this one and this one. And then when I plug in 4, 8 plus what is 2? That's going to be negative 6. So the answer is D. All right? Continuous, limit from the left and right have to equal each other. Differentiable, limit of the derivative from left and right have to equal each other. I did skip over the fact that f of 2 and f prime of 2 have to equal this number, but they were just whatever this one would be. So that's why I didn't write that. And the reality is, if you just kind of went to this on the AP test, that's what I would suggest to get to the point where you can just do that. I'm putting this video out. I want to at least have it be, I want the work to look, just in case anybody's like trying to really follow along. That's why I'm writing out all these steps. All right. Number 8. Which of the following is the slope of the normal line? All right, normal line is perpendicular to the tangent line. Let's find the derivative. So we're doing a little implicit differentiation here. Derivative of x squared is 2x. xy is the product rule. So that's going to be derivative of x is 1 times y plus derivative x times derivative of y, so dy dx equals 0. and I want the slope. So I'm going to plug in. I need to find the point. So I'm going to say 1 comma what? I'm going to figure that out here. So 1 plus y has to equal 3. So y is 2. Now I'm going to plug in 1, 2 here. So that's 2 plus dy dx is equal to 0. Solve for dy dx. So these steps I will. I'm hoping we're all solid with our algebra. 4, bring the 4 over. I get -4. So it looks like the answer is A. But wait, let's remember they said the normal line. The normal line is the perpendicular line. So the opposite reciprocal, which is going to give us positive 1/4. All right, number 9. All right, we're still working through the non-calculator portion of this BC practice test. All right, if g of x is the integral of f from 0 to x, which of the following values is the greatest? So let's try to think about this logically. So g of -3, we want the greatest, all right? G of -3 would mean I'm integrating from 0 backwards. Well, if I'm integrating from 0 and backwards, it's going to be the negative of integrating forward. And if I integrate forward, this area will be bigger than this area, so I'm going to get positive. So integrating backwards is negative. I'm going to assume that a negative number is not going to be the greatest. I understand that I could have like all negatives, but I just don't think that's going to happen. And if it does, then I will go back and reevaluate, all right? So if I look at g of -2, well, same idea. G of -2, I'm integrating backwards. I have an area that's above the x-axis, but that's going to have to be negative because, again, I'm integrating backwards. So no way that's the answer. G of 0 is 0. So I'm going to go out on a limb and say that's not the answer either, all right? And if they're all negative, then I'll go back and say that that's the answer because 0 will be bigger than all my negatives. But now we've got G of 1. Well, G of 1, we finally got a positive because I'm integrating forward and I have an area that's above the x-axis. So this is positive, so that's a good option. But now G of 3. Well, G of 3 means I'm going past 1. So that means this is positive and this area is negative. So I'm going to be taking some away from this area. So that has to be less than this. So without actually figuring out any areas, I can deduce that D is the answer. All right, number 10, we got a conceptual question here with, we got the graph of the function above, which has the greatest value. All right, so this is an increasing concave up function. All right, why that's important. A left Riemann sum is going to be an under approximation. Well, something that's an under approximation, and if you want to see that, just make one that's to the left. All right, that is under. All right, then that is not going to be the greatest. Midpoint, I am not. Yeah, I'm going to skip over that for now because, yeah, so there is a right. A right is going to be an over approximation. So I'm going to leave that going. And that is going to definitely be bigger than the midpoint. So the midpoint's now gone because the right will replace that. Okay, now the trapezoidal is going to be, and this is going to be the exact area. So we already have the right, which is going to be bigger than the exact area, so that's out. And then we have the trapezoidal sum. All right, well, since it's concave up, the trapezoidal is also going to be an over approximation, all right? But the trapezoidal will never be like as bad of an approximation as the right, given the same number of subintervals. So the trapezoidal, even though it is, so we got the midpoint is, we don't know if it's under or over. This is over, and this is over. And we know that the right will be more over than the midpoint, so that's gone. Now this is also gone, and the answer is C, because even though the trapezoidal is an over approximation because it's concave up, it will never be as bad, again, like I said earlier, as a right, as long as they're all equal subintervals. So the answer ends up being C. All right, number 11, Euler's method. So to approximate y of 1 when y of 0. So this is how I like to do it. I go, the point is at 0, -2. And if we think about like the linearization, I just relate it to this. Whoops. This is the formula, which is just point slope formula. With the y1 like moved to the other side. So I just think of this. I know this isn't directly how the exact formula you will see in a book with Euler's method, but all it is just using the point slope formula over and over again, and the point slope leads to the linearization. So this is just what I think about in my head. So f of a is like our y value. So I'm starting at -2. That's this. And then I'm adding the slope. Well, the slope is when I plug this point into the differential equation. So that gives me -4, all right? And then that is times the x minus a. Well, this x minus a is just the delta x, which is really just the step size. So I'm using a step size of 0.5. So this is going to give me -2 plus -4 times 0.5, and -4 times 0.5 is -2, and -2 plus -2 is -4. So that means the next point that I'm at, my x stepped by 0.5, and then I'm at -4, and I'm going to just repeat. So now I'm at -4. And I am going to do plus. Now I'm going to plug this point into the differential equation to get my slope, right? So that is 0.5 plus 2 times -4. Well, 2 times -4 is -8. -8 plus 0.5 is -7.5. And that, again, is multiplied by our step size. So this is, well, this is kind of annoying, without a calculator, but half of -7.5 is -3.75, minus 4 is -7.75. If you didn't want to do that, you could kind of, logically think that A is the only answer. And the reason we're done there is because if we step half again, we go to 1, and then this is our y value. So that's the answer because they want y of 1. All right, so that's a nice little quick review of Euler's method. Again, you can look like there's formulas like y naught, like plus the derivative, the differential evaluated at the point times the step size, but I don't know. I just related everything back to the easiest possible thing, which is point slope form, and then really I just think of the linearization formula. Okay, moving on to number 12, we have a conceptual problem here. The graph of f prime is shown. Which of the following could be the graph of f? So what I'm looking for is, these are the critical numbers, and I have above the x-axis, below the x-axis, and above the x-axis. When the derivative is positive, then negative, then positive, that is something that is increasing, then decreasing, then increasing. So A is wrong. Increasing, decreasing, increasing. Well, that looks good for now. Decreasing, automatically wrong. Increasing, decreasing, increasing also looks good. Increasing the whole time, that's gone. So now we've got to get more specific at, well, where are our because if we're increasing, decreasing, increasing, I have a max and then a min. And that has to occur like on the left side and the right side of the x-axis, which makes sense that it occurs here and here. It doesn't make sense for that to occur at 0. So the answer is D. All right, moving on. We have a just pretty straightforward chain rule here, but we got to remember some rules. So if I want f prime, well, I need to know that if I have a to the x, the derivative of a to the x is a to the x times the ln of a. All right, so the derivative of 4 to anything is 4 to that same thing times the ln of 4, all right? Then I need to multiply, I have the chain rule. So I got to multiply by the derivative of 1 over x. Well, you could think of 1 over x as x to the negative 1. So if you do the power rule, you get negative x to the negative 2, which is negative 1 over x squared. So then I am going to plug in 2. So that's 4 to the 1/2, which is 2, ln 4, times negative 1 over 2 squared, so that's negative 1/4. Well, now we're thinking like, where is our ln 4? I don't see that answer, because 2 times negative 4, 2 times negative 1/4 is negative 1/2. But what they're doing here is they're using log properties, and 4 is 2 squared. So if we look at it like this, the ln of 4 is 2 squared, or 4 is 2 squared. This 2 can come in front. So if that 2 comes in front, then that's like 2 ln 2. And the negative 1/2 times the 2 makes just negative 1. So I end up with just negative ln 2. So we've got to know our log properties for problems like this. All right, let's take a look at number 14. This one is pretty tricky. Okay, so they're giving us values, just select values of the second derivative, and we know that it's a continuous and differentiable function. All right, so we don't have to worry about any asymptotes or holes or jumps or anything like that. All right, so that is going to play a role, but we only know values of the second derivative. A, B, and C, all of them, we have to know something about the first derivative, because if f is increasing on intervals, we need the derivative to be positive. But in both scenarios, when something's increasing, it could be concave up or concave down. So knowing something about only the second derivative isn't necessarily going to help us figure out what's going on with the first derivative. Same thing with a local max. Yeah, we need the second derivative to be positive, but also we have to know that it's a critical value, which means with a derivative would be 0. So we don't know any of that. So those are just out. Now D and E, points of inflection, are related to the second derivative. Now D is very enticing, because if we look at it like this, if we say, okay, if it's a point of inflection, we would need the second derivative to be 0. Well, that's true here. And we would need it to be negative, change from negative to positive, which it looks like it does. Or it could change from positive to negative, which it looks like it does, but we're not sure that it does, because for all we know, when at 1 it could be positive, or at 1.9 it could be positive, and then at 2.1 it could be positive, or at 2.1 it could be negative, so it could go from negative to negative. So we don't have enough information to know. It says what must be true. We don't have enough information to know that there's a point of inflection at 2. Just because there's one value to the left that's negative and one value to the right that's positive, we don't know that, because we don't know that this is the only 0 on this interval. There could be others, and therefore the sign could change before it gets here. But what we do know, obviously this is the answer now, but what we do know is that from 0 to 6, it does change signs twice. It goes from negative to positive, and then from positive to negative. So there are at least 2 zeros and 2 sign changes, which means it definitely has 2 points of inflection. It very well could be at 2, but it doesn't have to be. There could be 2, so there are at least 2 points. It will be points of inflection. Now, just because it changes signs twice doesn't mean there's 2 points of inflection. It could change signs across an asymptote or at a hole. But we know that doesn't happen because they said it was continuous and differentiable. All right, so the answer is E. There's at least 2 points of inflection. All right, hope that helped. Okay, on we go. We are past the halfway point of this section as we move through the non-calculator part of our BC Calc practice test, the MCQ part, that is. So a particle moves along the x-axis so that its acceleration is that. All right, we got initial velocity, and we want to know when it's farthest to the right. So let's do it like this. Let's first find the velocity equation. Well, the velocity is the antiderivative of acceleration. So that's going to be 2 sine t plus c. And then they tell us that at time 0, it's at -1. All right? Well, that means that it's equal to -1 when I substitute in 0. Well, we should know sine of 0 is 0, so c is just -1. So v of t is 2 sine t minus 1. All right? Now I want to get an idea. I want to do a number line for this. And I want to find the critical numbers, essentially, of the v of t, right? So I set that equal to 0. I end up with sine t equals 1/2. And if we're on the interval 0 to pi, we should know that sine is 1/2 at pi over 6 and 5 pi over 6. And what's going to happen is if I take a number less than pi over 6, the y values are going to be less than 1/2 if you think about how the unit circle works. So this is going to be a negative. And then if I pick a value in between, which is easy, you just do like pi over 2, and then you get 2 minus 1 is 1, so that's positive. And then the same thing is going to happen over here. You're going to get a negative. Because if you pick a value past 5 pi over 6, but before pi, it's going to be a really small y value, and it's going to create a negative here. So what's happening is the particle's moving to the left, then it's moving to the right for a while, and then it turns around and moves left for just a little while. So that means at 5 pi over 6, it's going to be furthest right. Because again, it moves left a little bit, then right for a while, and then left just for a little bit. So this is the farthest right that it will get. All right, so again, the sign of velocity tells us which direction we're moving. And in these rectilinear motion problems, we're just moving left and right. Okay, 16. We're looking at the integral of this. So we're going to do a u substitution. I'm going to make ux plus 1, which makes du dx. All right, so then I go over here, and I'm gonna leave that x alone for a second. I'm going to have root u and then du. So that leftover x is a problem, but I go back to here and x is really u minus 1. So I get that. Now I'm going to do a little bit of algebra. Well, u is u to the 1/2, so u times u to the 1/2 is u to the 3/2 minus u to the 1/2. Now I'm just going to integrate with respect to u. Well, u to the 3/2 is going to be u to the 5/2, and then when I divide by 5/2, that's going to make 2/5. And then when I add 1 here, I'm going to get u to the 3/2 but I'm going to multiply by 2/3, and I'm going to have a plus c, and I'm going to stop there because I just need to find the answer where I substitute back in x plus 1, and that is clearly d. Yeah, because the exponents here are correct. So the answer is D. So do a little U sub, but you don't have to go all the way with it. We can kind of check what the answers are. All right, on we go to number 17. We want to know for which values for which the series converges. So I think what I'm going to do is I'm going to just do the ratio test. So we have the limit as n goes to infinity of a sub n plus 1, absolute value. A sub n plus 1 is 5 to the n plus 2 over x squared. Whoops. Here, let me do something here. Okay. So we're back. So we have x squared plus 1 to the n plus 1. And then if I divide by this, that's just like multiplying by the reciprocal. And that needs to be less than 1 in order for us to for it to converge, right? That's the condition of the ratio test. Okay, so we end up simplifying this. This ends up just being 25, 5 to the n plus 2 over... Oh, wait, that's my bad. This is n plus 1. I was going to say I didn't think there was a 25. Okay. 5 to the n plus 2 over 5 to the n plus 1 is just 5. And then when we have x squared plus 1 to the n over x squared plus 1 to the n plus 1, that leaves an x squared plus 1 on the bottom. And if it's the limit as n goes to infinity, that simply just is this. So I'm going to just like ignore this because the limit, there's no n's left. All right, so the limit as n goes to infinity, it's like saying the limit as n goes to infinity of 1 is just 1. All right, so I need to solve this inequality. So I get 5 is less than x squared plus 1, and then I get 0 is less than x squared minus 4. This is a nonlinear inequality, so 0 is less than x plus 2, x minus 2. And if I think of like a little sign analysis, I get negative 2 and 2. And when I sub that in here, I'm going to get plus minus plus. Right, so a number to the left of negative 2 is going to make these both negative. In between, only one of them, and to the right, both of them positive. So now I want to know when it's positive, so that's here and here. All right, so that tells me it's not this one, it's not this one, it's not this one, it's one of these two. So now I have to just check the endpoints, but I don't have to check them both because based off the answer, we're either including both or we're not including both. So I'm going to just check positive 2 because I think that's just easier than checking negative 2. So if I check positive 2, I make x 2, okay? So I get the sum of 5 to the n plus 1 over 5 to the n. Well, what that is just 5 to the n plus 1 over 5 to the n is just 5. So imagine adding 5 forever. That is definitely going to diverge. So that is going to be D because I don't need to check the other one because it's the only one that has, we're not including 2, which means we're not going to be including negative 2 based off of our answer choices. All right, number 18. Okay, so the graph above is f, and g is the integral of f. Find the equation of a tangent line at x equals 2. So what I want to do is I first want to know what the point is. So 2 comma something, and that means I plug 2 into the equation. So that means I'm doing the integral from -2 to 2. All right, so I got to find the area of some triangles. So the area of this triangle, the base is 3 and the height is 4. 3 times 4 divided by 2 is 6. Now I want the area of this triangle. Well, this has a base of 1 and a height of 2. So that gives me an area of 1, which means it's under the x-axis, so that's -1. So 6 minus 1 is 5. So that tells me the point that this is going through is 2 comma 5. And then the way that I want to find the slope is I want to just take the derivative. I want g prime of x. But g prime of x is just f of x. This is the second fundamental theorem of calculus. The derivative of the integral is just the integrand in here with x instead of t. So g prime of 2 is f of 2. And f of 2 is -2. Right? I'm just looking at the graph for that. It's just the output. So I need a slope of -2, so these are wrong. And then when I plug in 2, I need to get 5, and that's C. Right? So I'm going to write this out. I'm just going to plug it in, right? -2 times 2 is 4. Sorry, -4. And -4 plus 9 is the only one that gives us 5. So these don't make sense. All right, when you have to write your own equation, you just use point slope. But since these are in slope intercept, I'm just going to plug it into the answers really quickly. All right, on we go. Find all the asymptotes. So the vertical asymptote is going to be when 1 minus e to the x equals 0, which means 1 has to equal e to the x. Take the ln of both sides. And the ln of 1 is 0, so that means when x is 0. So x equals 0 is the vertical asymptote, so c and d are gone. Now I want to take the limit as x goes to positive infinity. Well, when I think about it this way, just so I can write a little less, the limit as x goes to positive infinity, the limit as of e to the x at positive infinity is infinity. So I'm going to get infinity over infinity, or infinity over negative infinity, but that's still an infinity over infinity. That's an indeterminate form. So that means I can use L'Hopital for that. And if I use L'Hopital, then I'm just doing the derivative of the numerator, which is e to the x, over derivative of the denominator, which is negative e to the x. The e to the x's cancel, and I just get -1. So y equals -1 has to also be an asymptote. So A is gone. So now I got to check, is 1 an asymptote? Well, that's going to be when I do the limit as x goes to negative infinity. Well, one thing we have to know about that is when we take the limit of e to the x as x goes to negative infinity, that is 0. So one thing you got to be able to picture is the graph of e to the x looks like this. So at positive infinity it goes to positive infinity, but at negative infinity it goes to 0, which means these are both gone, and I just get +1. Well, that is where this +1 comes from. So the answer is E. On we go to number 20. We're on the back stretch here of this test, or at least this section of the test. So we got this function. It's defined by another function, which is the g prime of 4. Okay, so let's find f prime. So f prime of x is the derivative of this, which is g prime of x squared minus 5 over 12 times 2x. I got to do the chain rule, all right? And it wants to know what is g prime of 4. Well, if I want there to be a 4 in here, then I need x squared minus 5 to equal 4. Well, I can do that pretty easily. If I add 4, I need x squared to equal 9. So x could equal positive or negative 3, but I don't see any negative 3's in my answer, so I'm going to say positive 3. So what that means is I'm really finding f prime of 3, because if I find f prime of 3, when I plug in 3 here, I'm going to get g prime of 4. Right? That seems a little tricky because 3 squared is 9, 9 minus 5 is 4. That's what I found out up here. And I want a g prime of 4. But I get that by plugging in 3 to f prime. And I'm plugging in 3, so that gives me 6 here. Well, 6 over 12 makes a 2 on the bottom, and I multiply the 2 over. So 2 times f prime of 3 is going to equal g prime of 4, and that's what we're asking for. So the answer is B, 2 times f prime of 3. All right, 21. What is the sum of the series? This should look familiar. This is like 1 plus x squared over 2 factorial, and so on. That is e to the x. All right, so this infinite series is e to the x, but we're replacing x with ln 5, and we should know that e to the ln of 5 is 5. So that one, if you really need to know you need to recognize the Maclaurin series for e sine, cosine, 1 over 1 plus x, or 1 over 1 minus x, really. And then you can get 1 over 1 plus x from that. So you really need to commit those to memory so that a problem like this is super, super simple. Okay, number 22. So we got a particle is moving along a straight line, and this is its actual position. All right, so we're looking at the position graph. It's telling us where it has a point of inflection. All right, so for what value is the velocity of the particle decreasing? So velocity decreasing. Well, let's think. Velocity is already the rate of change, and decreasing is the rate of change as well. So it's really talking about when is the velocity decreasing. That's when the acceleration, or the second derivative, we're going to call it x double prime, when that's negative. That's what we're looking for. Well, that is when the original graph is just concave down. Well, it's concave down from, what am I doing? It's concave down from here to here. And then the rest of the time it's concave up because this is our point of inflection. So that's between 0 and 3.5, which is answer choice D. All right, so it's all about understanding which derivative we're talking about and what the sign is, and then how to look for that on the graph. All right, number 23. Which of the following is equal to the area of the region inside the one curve and outside the other curve? Okay, so if we try to picture these, we should know that these are both circles, all right? And so they're circles that kind of, the diameter is on the y-axis because it's sine, and here the diameter, that's on a gray circle. The diameter is 3, and then for this one on the inside, the diameter is 1, okay? And we want it inside this curve and outside this curve. So we're looking for this area. Okay, so first of all, we also need to know with these circles to kind of get out the whole circle. You're integrating from 0 to pi, because 0 is going to put you here, and then you go all the way around, and then pi is going to put you back here, because the sine of 0 is 0, and the sine of pi is also 0. So that's going to kind of sketch all this out. So we're integrating from 0 to pi. Doesn't mean that that's the answer, because they could have done something with symmetry. So let's avoid crossing out answers that don't have 0 to pi. And then it is when it's the area in between them. All right. It is the big R. This is the integral of, it's also 1/2, the integral of big R squared minus little r squared. All right, so that is big R squared is 9 sine squared theta minus little r squared is sine squared theta d theta. And then 9 minus 1 is 8, and then if I bring the 8 out front, that turns it into a 4. So I get 4 times the integral from 0 to pi of sine squared theta d theta. But this is a problem, because I don't see that answer. All right? So what ends up happening is we have symmetry here. The right side of this and the left side of this are equal. So what we could do is, instead of integrating all the way from 0 to pi, we could just integrate from 0 to pi over 2 and then double that area. So that is why the answer is B, because if we go 0 to pi over 2 and then we double it, that's where the 8 comes from doubling 4. All right, so that's kind of a tricky one, because if you this would have given us the answer, but that answer is not there. So we have to know how to adjust our answers, and one of the ways to adjust our answer is by just using symmetry. All right, on we go to number 24. So we got this logistical growth model. It has a point of inflection at 200. Which of the following could be the differential equation? All right, so we really want to know the form. So this is what I'm going to write out. This is what I would kind of have committed to memory. Is the value of m is so this value, when it's in this form, this value m is called our carrying capacity. Right, which is just the maximum amount of the population based off of resources. So, and the inflection point always occurs at half of that. All right, so it reaches its inflection point whenever we're at half of the carrying capacity. So that tells us that the carrying capacity is at 400. All right, so that tells us that m is 400. So if I go over here, then I know I have dp dt is equal to kp times 1 minus p over 400. All right, so that's what I have right now. And it looks... So now it's kind of just comes down to which answer would give us that. All right, so what we're doing is, in order to get a 1 here, we're factoring out whatever this is. So like, for instance, in this one, I'd be factoring out a 2p. But if I factor out a 2p, I'm not going to get p over 400. And here, same thing here. So these are just wrong. So clearly, I'm factoring out a 0.2p, which means that k is 0.2. So if I look at this, I get 0.2p times 1 minus p over 400. Well, now if I kind of redistribute it, I'm going to get 0.2p minus 0.2p squared over 400. Well, 0.2 is 2 over 10. So it's like I'm doing 2 over 10 times 1 over 400. This makes 200, and this makes 1. So now I have 1 over 2,000. So I'm looking at the one that is 1 over 2,000, which that is the same as, so that's going to be C. Because if I kind of think about it like this, right? That's half of 1 over 1,000. Well, d would be 1,000th. And half of that, we would go to like the next decimal. We wouldn't double it. So that's why E and D don't work. Right? There's probably other ways you could look at it. But the answer is definitely C. So the key here is to know this form. This number down here is the carrying capacity. Carrying capacity is double 200. And then however you want to figure out the answer. I don't know if I explained that in the best way. But you just got to kind of like work your way through the algebra and checking your answers to figure out which one would fit that form. And you got to be able to do it without a calculator, which is kind of why I was going kind of all over the place with that. If I had a calculator, it would have been a lot easier. Okay. All right, moving on to number 25. We've got the Taylor series for sine x, which they're kind enough to give us. Which of the following is the coefficient of x to the 8th in the series for cosine of x squared? So I guess the reason they're giving us this is that cosine x is going to be the derivative of this. You should just know this, though. Like, we should just know that this is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And that's where I'm going to stop it, because I am going to be subbing in x squared for x, and x squared to the 4th is x to the 8th. So this is the only one I need to know. So they gave us this in case we forgot it. We could just take the derivative of each of these terms, right? The derivative of x is 1. X cubed is 3x squared over 3 factorial, which is x squared over 2 factorial, and so on. But cosine is one that we should just know. I think that's really helpful to know that one. So now we have the cosine of x squared. And I'm just replacing each x with x squared. So that's 1 minus x to the 4th over 4 factorial. And then plus, I don't know why I did 4 factorial. That's 2 factorial. I was looking at this one. Then we have our x to the 8th over 4 factorial, which means that the coefficient of x to the 8th is 1 over 4 factorial, which is 1 over 24. And that is answer choice C. Okay, number 26. All right, so we have a function where they're giving us f double prime. The graph is tangent to the line at that point. What is the average value of f on the closed interval? Okay. So what we know is that we want to find, so let's just start with what they're asking. They want the average value. Well, that's 1 over b minus a, so that's 1 over 2 times the integral from -1 to 1 of f of x dx. Well, I don't know f of x. But what I do know is I do know f prime of x. All right? Or sorry, I know f double prime. So I can work backwards. So that means f prime is the antiderivative of 12x plus 8. Well, that is 6x squared plus 8x plus c. What I also know is that this tells me, if I kind of switch places here, 2x plus 2 equals y. Well, that tells me that the slope is 2 when the x is 0. So that means f prime of 0 has to equal 2. All right? Well, if f prime of 0 is 2, then that means when I plug in 0, c has to be 2. So f prime of x is 6x squared plus 8x plus 2. Okay, but I still need f of x. Well, f of x is the antiderivative of this. Well, actually, I don't know why I'm doing that. Oh, no, I do need to do that. That's my bad. So we do need to keep going. So now we have 2x cubed plus 4x squared plus 2x plus another c. But I know when I plug in 0, I get negative 2. So there's 0, 0, 0. So that means I'm just going to put a minus 2 here. Never mind. I'll erase it because that looks... So I have a minus 2 here. All right. Now I have f of x. So now I need to do 1/2. This one is a doozy. It's not really that hard. It's just a lot to do. Integral from -1 to 1 of 2x cubed plus 4x squared plus 2x minus 2. So that's 1/2. Another antiderivative. So we get 2x to the 4th over 4. So that's 1/2 x to the 4th plus 4/3 x cubed plus x squared minus 2x. Wow. And this is all evaluated from -1 to 1. Woo. This is a lot. I don't know if you'd ever have to do this much calculation on a non-calculator part, but let's keep powering through. So let's plug in 1. So when I plug in 1, I get 1/2. I'm going to put this over here. I get 1/2 plus 4/3 plus 1 minus 2. And then I'm going to plug in -1. I'm going to do it like this. When I plug in -1, I get 1/2, I get minus 4/3, I get plus 1, because that's squared, and then I get plus 2. So now I'm going to subtract these. So 1/2 minus 1/2 is gone. 4/3 minus -4/3 is adding them, so that's 8/3. 1 minus 1 is gone, and -2 minus 2 is -4. So finally, well, not finally, I do over 1. Well, this is like 12, so this is -4/3. But then I'm multiplying by this half in front. So that's times a half. And finally, I get -4 over 6, which is -2/3. And I think that is finally the answer. All right, every piece of that is important, starting from the starting from the second derivative and taking the antiderivative, and then the slope of the tangent line is really what the derivative is equal to at 0, and then anti-deriving that, if that's a word, using that, then taking the antiderivative again and doing the average value formula. That one is a lot, but we should know how to do all that. Okay, moving on. We've got 2 left. So let's take a look at number 27. We got a polar problem. Which of the following expression gives the area of the petal, of one petal, enclosed by the polar curve? So let's kind of do this using, in a way, process of elimination. So no matter what we integrate between, we are going to have to do our 1/2 integral of r squared. Well, that's going to be 4 cosine squared of 3 theta d theta. And the 4 and the 1/2 are going to make 2. Again, this does not mean that that's the answer, because they could be doing some symmetry things here. But let's go through each answer. So if you look at A, it's going from -π/2 to +π/2. Which doesn't seem to make sense to me. Because what's going to end up happening is, like, if we just look at one petal, let's look at the other way for a second. If we just look at one petal, we want to think, like, okay, well, what's going to give us this 0 here? right? And what's going to give us that 0 here is pi over 6, because pi over 6 times 3 is pi over 2, and the cosine of pi over 2 is 0. So then the pi over 6 is what's going to get us here. And one way to do it is to integrate from negative pi over 6 to pi over 6. That would give us this pedal, all right? But then, again, I think what they're doing is a little bit of symmetry, because if I just integrate from 0, 0 is here, because the cosine of 0 is 1. So 0 to pi over 6 is going to give me this half of the pedal. And then if I just double that, that's going to give me the whole thing. And that's what they're doing in C, is when I double this, I get 4. All right, so all the other limits just aren't really making sense. Like negative pi over 2 to pi over 2 would be going way too much. Like if you think about it, if you plug in negative pi over 2, that's negative 3 pi over 2, which is here. And then going all the way to positive 3 pi over 2, that's just integrating way too many pedals. All right, so it's got to have pi over 6 in it. So these are out. And then 0 to pi over 6 to 2, that doesn't match. And 0 to pi over 6 taking half of that doesn't match. So what they're doing is they're taking advantage of symmetry again. They're doing half of that pedal and then doubling it, which is where the 4 is coming from. All right, so like I said earlier, really be careful when you're matching up integrals to answers of integrals, like just getting rid of answers too early, because a lot of times they'll take advantage of symmetry. So an answer that looks like it won't work all of a sudden like does, because they're changing the limits and using symmetry. All right, we are on the last one here. So this particle moves to the right along the parabola. If the particle moves at a constant speed, which of the following is the velocity vector of the particle at the point 4, 8? All right. I need a minute to think about this one. So speed so at this point, the velocity vector will be like dx dt comma dy dt at that particular like time. And the other information they give us in the problem is that its constant speed is root 104. And we should know that speed is dx dt squared plus dy dt squared and the square root of it. So it's basically, it's basically, just a Pythagorean theorem. So they're telling us that that's equal to root 104. All right? And that just means that dx dt squared plus dy dt squared is equal to 104. That's what we have so far. All right? And then if we want to get dy dt in terms of dx dt, we just take the derivative of this. So I'll go over here. So dy dt is just 2x dx dt minus 3 dx dt. And then we go even further and we say, well, dy dt at this point, when x is 4, is going to be 8 dx dt minus 3 dx dt, which is 5 dx dt. So that tells me that dy dt is 5 dx dt squared. So dx dt squared, well, 5 dx dt squared is 25 dx dt squared, plus this is 26. So we get 26 dx dt squared is equal to 104. All right. Well, 104 divided by 26 is 4. So dx dt is plus or minus 2. But as this particle is moving this way, the x-coordinate is moving right, so it definitely is positive. So dx dt is 2, and that eliminates c, d, and e, because I need dx dt to be 2. And then dy dt is 5 times that, which is a, 2 comma 10. That is a very challenging problem. That's one of the harder ones that I've seen on an MCQ related to especially this topic. Okay, that concludes our first MCQ section non-calculator. Stay tuned. In the next video, I will attack the calculator MCQ section. All right, hope that helped.